So anyways, we use these two formulas to actually get a little quiz exercise done. And also turns out there is another set of formulas that deals with the functions with logarithms of different bases. For example, if you have the derivative of b, they like to use letter b, so use the same, to the power of x, it'd be analogous to the formula above, but it'd be multiplied by ln of b. So ln of b appears and it's multiplied by e to the power of x. So since it's something multiply, I better put parentheses so it kind of separates them. And with the logarithm of base b, so not ln, which is logarithm base e, but any other letter, let's say b of x, is still going to be 1 over x, but in front of it or after will be ln of b. So the point of story that natural logarithm appears. It's not hard to justify these two formulas, but I guess our goal is to make sure that we know how to use them in this class. So there are two more formulas that I deliberately didn't talk about last time. I just left it for today. And we also had a little quiz, I believe. Let me find the exercise. It was somewhere in the very beginning. So I think it was like the first problem, e to the power of 5x, or something else. I think like exercise 1 for quiz, if I remember it right. So if you take e to the power of 5x, instead of x, we have 5. So it's going to be a chain rule used. So same e to the power of 5x will stay, but multiplied by derivative of power, which is 5x, and this is just 5. So people usually put 5 in front, or some people, when they did quiz, they put times 5. Well, it doesn't matter because when you multiply, factors commute. Commute means you can multiply them in any order whatsoever. So that was nice little quiz exercise that we had, and that's, I guess, the way to go. So I'd like to do some more problems from this section. I think that'd be all we need to do to continue. But first of all, I need to say that they sent me emails saying that not too many people from class actually did this student evaluation. I believe last week or so, they sent you email, the college, with a link so you can click on it and do this little student evaluation. And I think like 4 people from class only did it. So what I think we'll do today, instead of giving you a quiz at the end, I'll just stop, and the rest of time you can check your email because I don't have it, and fill these student evaluations because they want to see more responses, because it's just 4 people. It's really not too many. We have 30 something in class. So anyways, I also want to remind those people that did not send me their homework, and there are still some people that I hope work on this. Well, send it to me, email it to me, because the time is passing by. Next week, November is going to start, and November is the last month, because I believe at the very end of November, we have the final exam. So just 1 more month, it's not much time, plus months of November, we have a long weekend, the Veterans Day. Oh, that's Friday, I think. Not sure what day it is, but Thanksgiving, it's another weekend. So usually when it comes to November, it's already like the end of semester. That's why you should, yeah, it runs by really fast. That's why you wanna get rid of this midterm homework, because now we're gonna move on and there'll be a different story, and that's why we really should be done with that midterm stuff. I still accept if you want to redo the midterm or the homework if you didn't send it to me, or if you send me everything and say, Alex, I also want to get some extra points. Well, just do a few problems and send it to me as extra credit. I always say a few problems of your choice, whatever you decide to select, but make sure you tell me that this is extra credit if you decide to do that. You don't have to. Your grades are on Canvas. If you can't retrieve it for whatever reason, let me know. I will tell you what it is, because sometimes things happen, I know, but I keep track of all of the grades. So anyways, let's do a few problems with logarithms that have not base e, but other bases. So for example, let's go down a little bit, find something with different base than e. Well, it looks like problem number 35 has 2 to the power of x. And that's going to be the logarithm of a quotient as well. So if you have a quotient, in other words, if you divide two functions f by g and try to find their derivative, and notice in 35, we clearly have 2 to the x divided by x. So we do have that quotient. So denominator is squared, and we have to take derivative of numerator times g minus derivative of denominator times f. So let's see what we can treat as f and g. So I'm going to write it as 2 to the x divided by x itself. So this is what I need to differentiate. So let me prepare. So for numerator, function f is 2 to the x power. And the second one, function g, is just x. And to find derivative of g is a pleasure because it's 1, right? Derivative of x is just 1, and that's good. Now, derivative of f, well, it's going to be the same thing, but multiplied by ln of 2. ln of 2 is multiplied by same 2 to the power of x. So that's a new formula. So I just replaced letter b here and here with a 2. And actually, sorry, it's b to the x, it's not e. You just need to be careful. B stays. So we're gonna set up that fraction is a difference, and denominator will be squared. So the difference of f prime, this is ln times ln of 2 times 2 to the power. And then we subtract g prime, which is 1, is multiplied by function f. Well, that's 2 to the power of x. So I recommend to leave it like that. Because yes, you can factor out 2 to the x and then what? So you're going to just rewrite your denominator in a factored form, but there's no need for it. But if you really want to, I'm not going to stop you from that. It is really up to you. I don't see many formulas on these. I think maybe we should go a little bit farther in the section, because I don't see any exercises that deal with this 2 new formulas, because everything is e to the x or ln, which is logarithm base e. So it's pretty odd that the book does not have many problems of that kind. Well, it's okay. I just wanted to introduce you with those, I think number 36 is another one. Let me do it. That's another one I found. See, I tried real hard. So 36 and maybe 37, 30. Let me do one of them, 36. So it's analogous, but now for a change, it's a multiplication. So every once in a while, you deal either with a quotient or a product that you cannot really do anything with. Like here, we have x squared, which is multiplied by 3 to the power of x squared. You say, oh, why is it x squared here and there? It doesn't matter where it is. Don't worry. It's just some random exercise, and all you do is just simplify it. And the way you simplify is you use the formula for derivative of product. So f times g. So it's f prime g plus g prime f, like that. So this is our formula. So I need to take derivatives of those ingredients. So if my f and g are going to be pieces x squared and 3 to the power of x squared, right? Then what are their derivatives? Well, we'll take derivative of f as favorite, right? It's 2x, right? The power form. For derivative of g comes a new little formula for derivatives, and looks like, again, I'm using this b to the x story because it's 3 to the x squared story. So it's ln of base, ln of 3, which is multiplied by the same exact thing. But that's not it, because we have chain rule. It's always around. So if you are looking at the power of 3, which is x squared, then I have to take it and times it by derivative of x squared, which is 2x. So now it's a time to set this structure. So let's do this. What is f prime? Well, that one is nice. It's 2x. And then I just take function g, and that's my 3 to the power x squared. That's a good start. Now plus, now I need g prime. And that's going to be a bigger structure. So I can put maybe, well, exact same way. It doesn't matter in which order we have these factors. They're just multiplied like that. And finally, I must also use function f itself, which is times x squared. Well, some people may want to put x times x squared, which is x to the power of 3. But other than that, there's really nothing you can worry about in here. So we've got this derivatives using different base. But again, I'm a little bit surprised they don't really have many exercises of that type here. So next sections, they deal with word problems or so-called applications. And applications vary for exponential functions, various areas of sciences, biology, and statistics. This is example from statistics. I know if you never took statistics, you might just panic, and this so-called normal distribution we have here. And if you never took these classes and never wanted to be biology major, where they calculate bacterial growth, how fast bacteria multiplies, or physics major, if you're studying some nuclear reactions, half-life of various elements, then you probably don't need it. And that's why I don't want to make people panic, because these are all same things. You take function, you find its derivative, and that's about it. So the rest of the chapter is all the same that I skip, because I told you not to worry about word problems. And it's just two little sections. So I just want to give you a little flavor of next chapter. And this flavor is in going backwards from derivative to so-called anti-derivatives. Just like we went from exponent backwards logarithm. So it's analogous procedure. So they say that if, for example, derivative of x squared is 2x, then if you want to go back from 2x to x squared, what you use is so-called antiderivative, the opposite procedure. And the way to do it is write integral and then dx. So for derivatives, it's simple. You just put this little prime. But for antiderivative, you have to put two pieces, integral and dx. And that's how you get to it, x squared. So if you know how to find derivative, well, then you just go backwards and you find the antiderivative. So I guess I'll just start talking a little bit about this section. I'm not going to be getting really deeply into it. I'll just tell you a few words because I already introduced you with two new formulas just to finish the story of that previous chapter. So it turns out that there is a special, see, they have this little idea with 3x squared. So it's x cubed is antiderivative. So how can you actually verify that it works? Well, I guess the most important formula here is the power rule for the antiderivative. So if you put now is two pieces, again, integral and that dx. So always with x goes dx when you have antiderivative. So the formula says you need to add 1 to the power. Remember, when we took derivative, we have to subtract 1. So the power was 2, so then power is 1 smaller. And then you have to take that 2 and multiply by it. So instead of multiplying, you're going to divide by that. N plus 1. And also they put something like a constant. That's something we're going to talk about later. So what I want to do is actually double check what happens if I take antiderivative of 2x dx. Please notice 2 is an assumption that is multiplied, so it doesn't really play much role in this process. Just like with derivatives, if I multiply by the constant is still be multiplied. So what I need is to use the formula that I just wrote. So I'm going to keep that 2 multiplied. Now x will be raised to the power n plus 1. So the power used to be 1. I put another plus 1, which is 2. So I put that 2 on the ground, in denominator actually. Keep that constant. And notice that 2 and the 2 cancel, so you end up with x squared that we started with. I started with x squared. My goal was to actually produce it backwards. And the formula gave me ability to do that. So I guess another procedure and another formula will be associated with it. So I just want to maybe do a couple of exercises, and that should be good enough. So you see this formula today, and then next time when we talk about this again, you'll say, oh, that looks familiar. We already saw this before. So I'd like to take antiderivative in exercise 3 of x to the power of 5. So how can I do this? Well, just use the formula, right? So let us use that little formula. So I'm going to write this as a antiderivative of x to the 5. dx. So I'm gonna need to add 1, right? Put 5 plus 1. Again, I'm looking at this new procedure, going back from what we had differentiated to get x to the 5th. And then in denominator, we see this exact same as a power, so that'd be 6 and a constant. So x to the power of 6 over 6. If you decide to check and see if you get a derivative that brings you back to where you started, to x to the 5th, well, if you differentiate, x to the 6 will give you, well, derivative put here, will give you x to the 6, subtract 1 is going to be 5, and 6 is in front, right? Remember how we found derivative? Or you already forgot? So let's say, Alex, I took the midterm and I forgot. Well, I'm not going to ask you to do these exercises again for the final. It'd be totally separate exam, but it uses the ideas of derivatives pretty heavily. So we should not forget for another months. So what's the derivative of constant? Remember? 0, right? 0. And look at what we get. 6 and 6, they cancel. And indeed, x to the power of 5 is resolved. So just going backwards, and the good thing about it, you can always check if you did it right, because you know how to find derivatives. And that's something that you don't have to do, but if you have time, and you will have time, I will give you plenty of time on the final, just like on the test, then we should be fine. So what about exercise number 5, where you have this 1 over x squared? Well, remember, I don't want to deal with those fractions. I always want to rewrite them with a negative power. So instead of fractions, I try to always get negative exponents and so forth, because we have formula only for the powers. And the formula says, take your power and add 1. Just add 1. And then divide by exactly the same result, so it's a -1. And don't forget to put the constant. So when I divide something by negative, it's going to be negative, and x will be raised to the power of -1 minus 2 plus 1 plus the constant. And people usually like to bring x down because the answer should have no negative powers. So if power was -1, then you can bring this down to denominator and have x to the power of +1. But the negative in front is going to stay with us. It's not going to disappear. So maybe one more. How would you like them? One more and that's it, I promise. I really love them. That's, I guess, not an issue, but I want to do one with a square root. So we can practice one more, and then I'll let you relax a little bit and ask to fill the student evaluations, because even they send me email, it means they definitely want to see more of those. So they wanted me to remind you of it, and I think it's be good instead of quiz that you fill the student evaluations, right? So 7. The square root function, it's the same as if you had t to the power of 1/2, isn't it? Square root is power of 1/2. So what I want to do is write this as a 2, and 2 I can multiply by, so it takes out. Yes, the student evaluations were sent to you by the college. If it accidentally was deleted, check your deleted box. It should be there. It usually stays there for months. But yeah, I also delete all kinds of things. That's why I'm not surprised that they could be deleted. But yeah, they sent it last Monday or even week before. And they sent it from, I think it's either climate controls or something like that. And that'd be nice if you could fill it. So anyways, the 2 is factor is multiplied by 2, so 2 stays. And now for the power of t, I just need to add 1. So -1/2, I add 1 to it. So what's -1/2 plus 1? Is that going to be just 1/2? Because you technically take off from 1/1/2. So get $1, you lost half of it, so another half is left. So it'll be 1/2, in other words. So I just write it the way it is, plus the constant. And I know that's kind of annoying to have 1/2 in denominator, so people sometimes either flip it, or there is a neat way to clear denominator. So denominator is 2. That's what I want to cancel, right? So I need to put a 2 in the numerator and in denominator of your fraction. So that way this 2 cancels and 2 appears on the top. Or if you flipped 1/2, 2 will go on the top anyways. See, there's a little bit of arithmetic here. So it's 4. And now t, we already know the power, it's 1/2, right? And the constant added. And finally, it's a square root, right? Square root t and plus the constant, just like that. So we have the result. We'll do more of them because there are more and more of these antiderivatives on this page. So don't worry. You don't want to look any farther than that, please, for now, because it's just the first encounter. So as promised, I'm going to stop at this stage. I'm going to stop to record. And I guess I better log out to let you do the evaluations.